Welcome to Basic Tutors YouTube channel. In this channel, we will be breaking down topics of each science subject in order for you to have a better understanding of each topics. Because as a teacher, we believe that every student should understand fully every topics they are being taught. So, in order not to miss out on any of our videos, because all the videos we'll be uploading are very important, please do well to subscribe to our YouTube channel. Also, like and share. We also have a Telegram channel where you can communicate with us, ask questions, and meet with other educators. The link of our Telegram channel is in our YouTube bio and comment section. Now, say these after me. I understand mathematics. I understand physics. I understand chemistry. I understand further math. That is a spirit. Basic tutors. Excellence is our watchword.
Good morning, beloved. How have you been? Happy Monday morning. We want to use the privilege to appreciate everyone who viewed our first, second, and third video. As far as index notation is concerned, we appreciate you all. Don't forget our channel on Facebook, on Telegram, on TikTok, likewise on YouTube, Basic Tutors for Science and Technology. We appreciate those people who subscribe. We still need more subscribers as you resume today so that you can watch our videos. We'll be releasing a lot of videos soon as regards mathematics, physics, chemistry, further mathematics, likewise computer. All this will be handled by competent tutors. So we want to assure you that it will be a nice time after you've been to your various schools. You come back home, sit down, relax, then have a revision class with us because we'll be teaching those topics deeply and we'll be focusing more on first term topic in SS1, SS2, SS3 and mathematics in GS1 to GS3 and likewise computer GSS1 to GS3 and likewise database for SS1 to 3. Those things we'll be doing. So we can assure you we've started with indices. In days to come, we'll be releasing more videos as far as physics dimension is concerned and the major SS2 topic and SS3 too as well. So just stay tuned with us as we embark on this sound academic journey. Our subscribers, we appreciate you. We still need more subscribers, more followed up on TikToks, on Facebook, on Telegram, on YouTube. Just search for Basic Tutors for Science and Technology. You will see my picture and that of my lovely wife there. Thank you. We love you. Enjoy the whole teaching as we start now. So this morning we'll be looking at the measurement of physical quantity. That's your first topic in physics in SS1. So we'll be discussing, we'll be having the sharing knowledge about the basic foundation of physics, whereby we'll be discussing a lot of quantities. Primarily, there are two types of quantities in physics. We have the fundamental quantities. We call it the mother quantities. These are quantities whereby other quantities depend on for definition and expression. That's the fundamental quantities. Then we also have the derived quantities. The derived quantities depend on fundamental quantities for definition or expression. So we'll talk about the fundamental quantities, how it's being derived, then we'll do a lot around the derived quantity. Then that will now lead us into the dimension of quantities. You know, in physics, you can't do without quantities. Now we talk about electric current resistance, we talk about heat, we talk about work done, we talk about energy. All these are still around quantities. So all this will be analyzed this morning. Then we'll now move to little dimension. Handling the dimension, we discuss some things around past questions as far as dimensional question is concerned. So join us as we do all this derivation. There are things you have to practice, especially those of you in SS1, SS2, SS3. You have to practice it as many times as possible. Dimension is one of the important topics in physics in your WAEC and LEGO. So it's very important, especially in your WAEC theoretically. It's always your number one or number two question. So join us as we continue in the journey of these academics. Thank you. Measurement of physical quantity. So we'll be discussing some theoretical concepts before we move to the calculation aspect of the topic. The quantity is the property of a body or a substance that can be measured. So the property of a body or a substance that can be measured is known as quantity. An example, we have the length, as the way a body is, maybe like a box or a rectangle, you can measure the quantity as length. We have the area too. An object can be measured with the area, and the area is length and breadth. The volume of a substance or a body can be measured. Primarily in physics, when we talk about a body is not necessarily a human body. A body is synonymous to matter. Anything that has mass and occupies space, we call it body in physics. So it's not just body as the way you learnt it in biology or in your basic science. No, body is either an object that has life or object that does not have life. Human being is a body. In physics, a car is a body. So a body can be used for anything, but whether it is a matter, anything that has mass and occupies space, we refer to it as a body. Then the volume. The volume is also an example for quantity. It's a property of a body or a substance. Then speed. We see have velocity and many other ones. Velocity, acceleration, work done, energy, all those things, they are all quantity. They will still be discussed. And that's the basic foundation of physics, especially. That's the basic foundation. Everything you'll be doing from SS1 to 3, they are all expression of quantity. Is it heat energy? Is it light? Is it sound? Is it electric field? Electricity, magnetic, radioactivity, the nuclear phases, and energy quantization, and many other things, they are all quantities. That's what you'll be learning in physics all through, even in your chemistry too as well. Then we'll talk about the unit. So as we discuss on quantities as the property of a substance, the unit is the yardstick to which a quantity is being measured. You know, we can say in the layman language that we use unit to measure quantity. When a quantity is measured, we describe the quantity in unit. For example, now, this length has a unit of meter or centimeter. So the yardstick in which a quantity is being measured is known as the unit. Area will be in centimeter square or meter square. We have the volume as centimeter cube or meter cube. We have the speed as meter per second. Because speed is distance over time. All these derivation we are still going to do mathematically in form of an expression. And I hope you know that also physics is just application of mathematics. So mathematics is the mother of all. So all this will be more clearer as we start. So as far as the unit is concerned, it is the yardstick to which a quantity is being measured. E.g., we have centimeter, we have kilogram, we have seconds, and many more. So fundamental quantities can be split into two. We have the fundamental quantities and derived quantities. So we'll be looking at the first type of quantity. Now don't forget, quantities, which is defined as the property of a substance, can be divided into two. We have the fundamental quantities, we have the derived quantities. Let's look at the fundamental quantity now. These are basic quantities that are independent of others or that cannot be defined in terms of others. Fundamental quantity is like a foundational quantities. We can't do without them. They are the expression at which derived quantities depend on. That's why you hear the word derive. This fundamental quantity is the primary quantities. It is the basic quantities in physics. All other, it does not need another quantities to express itself or to define itself. But when it comes to these fundamental quantities, it's independent. It does not depend on any other thing. So we listing them. This is example is length, mass, electric current. We still have the amount of substance too. We have time too. It's an example of a fundamental quantities. So those are the five basic examples of fundamental quantities. We are still going to analyze them. Then in the next, after cleaning the board, we'll be looking at derived quantities. Then later we'll start the derivation. And the derivation, theoretically, my explanation I know is clear enough, but calculation wise, just look at the way we are going to simplify the whole expression. And you must be able to sit down and derive your own in your closet as we are starting the journey today. That's the first topic your teacher will teach you in school. As far as your SS1 physics is concerned, just follow along with me as we embark on this journey. You will find it very interesting. Remember, you can do this do the calculations around it, you build up your self-confidence for some other topic in physics as we also journey ahead. Love you. Fundamental units. So these are basic units that are not dependent on other units. This one does not it also does not depend. Same way fundamental quantities does not depend. Same way unit does not depend on other units too. So the fundamental quantity does not depend on other quantities. Likewise, the fundamental unit does not depend on other units. And we said at the initial that in our initial conversation that the unit is a yardstick of at which a quantity is being measured. So when you express unit is an expression of a particular quantity or the way in which you identify a quantity. Talk about length, and I'll talk about meter or centimeter. So that's that. But other units depend on them. In other words, they are unit of fundamental quantities. So that's fundamental unit for you. Example is meter, kilogram, seconds, ampere. That's for current. You have Kelvin, that's for temperature. Then and mole, that's for amount of substance. So in a tabular form, we have the quantity, the SI unit, then the unit abbreviation. One, length, the unit is meter. M, mass, kilogram, kg, time, seconds, S, electric current, ampere, A. So we'll also be looking at other quantities. So the temperature for the fundamental quantity. So temperature is one of the quantity. The unit is Kelvin. The unit abbreviation is denoted with K, where the amount of substance, mole. Then the unit abbreviation is MOL. The luminous intensity too, we have candela, that's the unit, just to determine the intensity of light. Then CD, that's the unit abbreviation. So that will now move us to what we call derived quantity. Derived quantity. From the word derived, that means taken from something. So these are quantities obtained from simple combination of fundamental quantities. Examples are, that means derived quantity is an expression of fundamental quantities. This one now is dependent. It's not like fundamental quantity that are independent, but this one is dependent. It depends on fundamental quantity, just like a parent. A child will depend on his parent for survival. Although we all depend on God, but fundamental derived quantities is like a child depending on his parent. The parent is the fundamental quantity, but the child is the derived quantity. Later the child will grow up and turn to fundamental quantities. Is the grandchildren will now, or the grandchildren, his own children rather, which happen to be the grandchildren of the parent, would be depending on their parent. So you get that family analogy. Same illustration too. So the derived quantity does not have an existence of its own. It will depend on fundamental quantities. It has to do with the combination or accumulation of fundamental quantities. For example, now we have starting with area. The area means when you open area, you meet length and breadth there. So the length and breadth are fundamental quantities. Volume. When you open volume, you meet length and breadth and height there because it's length and breadth and height. That means volume depends on those three quantities, length, breadth, and height, for its own expression. If you look at force depends on mass and acceleration. Mass is a fundamental quantity, but acceleration is also a derived quantity because acceleration depends on velocity over time and time. So that's that. Density. Density is a derived quantity because density is mass over volume. So and you know that mass is a fundamental quantity, but volume is a derived quantity. So even a derived quantity can still depend on a fundamental and also a derived quantity for expression. And when you open the volume, you're going to meet length times breadth times height there, which means it's still a fundamental quantity. Do you get the analogy now and the illustration? Thank you. Derived units. These are units that are obtained from a simple combination of fundamental units. That is, they are derived from and depend on fundamental units. Just as we said, the fundamental quantity depends on derived quantity depends on fundamental quantities. Likewise, derived unit also depends on fundamental units. So, for their own definition and expression, examples are we have the meter squared, we have the meter cube. The meter squared is for area, the meter cubed is for volume, the meter per second, that will be for speed or velocity, etc. And many more. We have density. Density that will be kilogram per meter cube. So all these things will still be analyzed. So we will be moving to the calculation aspect now. And this should be the area that should be more interesting. Physics is both theoretical calculation, and practical. Along the line, we are still going to be doing analysis that involve physics practical and that of chemistry practical too. You find it interesting. We'll teach you practically how to write table, how to plot graphs in physics, how to interpret physics question. That's the practical aspect. And practical is if you can do your practical 100% okay. If you are okay practically in 100%, automatically you have 40% of your mark sealed in physics and chemistry. So the remaining work will just be on the theoretical aspect and the objective. So all this will still come across, and I can assure you before December, we'll be able to start the physics and chemistry practical fully. We will do something like an alternative. I will explain some things to you later. We are going to go into the practical session whereby you will see all the apparatus too as well. As far as the physics practical is concerned, we'll be doing a lot of analysis. So what that's why I said get subscribe to our YouTube page. If you get subscribed to our YouTube page, there are a lot for you beyond the little you do to your data. I can assure you. Literally, you won't have issue with any question as far as your journey in SS1, SS2, SS3 is concerned. You will be able to say on your word that how many tutors help you to achieve your academic goal. And the basic of all these things is so that when you get to university, you won't be stranded. Either you are studying medicine, either you are doing engineering. Like me now, by the grace of God, I'm an engineer. But yet, that does not mean we can't do the breakdown of physics, chemistry, mathematics, and further mathematics. Those are those things you need to take note of there. So please just join us as we continue. So we'll be doing a lot of derivation this morning. We'll be considering some quantities, how do we derive them, and you have to pay attention to them because this is the basic foundation for your physics calculation. So the more you get this right, you find it easy more to relate with physics calculation. Thank you. Dimension is the physical nature of a quantity. So the physical nature of a quantity. When the one thing you should take note of in this topic is that we did the derivation of both the unit and the dimension of a quantity. So we'll be doing the analysis. For length now, the dimension is denoted with L. Please take note of something. You always put it inside a bracket, the dimension. That of mass is denoted with M, time is T. You realize that we are concentrating majorly on the fundamental because it's from the fundamental we do all those derived too. So that's that. Then I will clear the board now as we proceed. We'll be doing a lot of derivation. As we derive the unit, we also derive the dimension so that you can follow us up. So derivation of unit and dimension of quantities. So derivation of unit and dimension of quantity. One, we are starting with area. So we want to derive area. So please look at me. We are starting with from scratch. You must be able to know the quantity that form area without looking at your textbook or your notes. So we start with the length times breadth. So for the unit, is in length is in meter, the breadth is meter. So you know just from your knowledge of indices, this is m raised to power 1 times m raised to power 1. And that will be m raised to power 1 plus 1. You know, law of indices, you added it. That will become m raised to power 2. So that's your unit. That's your unit. Still, that's why I said physics is still application of mathematical science. So that is done. Then for your dimension, if you remember, that means length is denoted with L, then breadth is still the same thing as L. So dimension is denoted with L, so the dimension will be L square. So that's the dimension for area. So in case they ask you your why, what is the dimension for area? For area, that's S square. From there, we'll move to volume. Number 2, volume. We have length times breadth times height. So for the unit, the length is meter, the breadth is meter, the height is also meter, and that will be meter cube, m raised to power 3. So for the dimension, the length is L, the breadth is L, and the height is also L. That would be L raised to power 3. Can you see? L raised to power 3. You see the way we bracketed it? So bracket it rather. So you can see the way it is. So you realize that that's the dimension for that. Then that's for volume. The next one is density. Do a lot of things around such. So density, density is mass. Density is equal to mass over volume. So when we open density up, we have mass over volume. So in terms of the unit of density, we have this kg over volume is m cube, or in some textbook they apply the negative law of indices. This one can come up and this will carry a negative value to be like kg m raised power minus 3. You still remember it's still applicable for your indices. That is, when the denominator has a power and you want to make that denominator to become a numerator, the power of that denominator will be negative. So you see it like that. Then we also have, in terms of the dimension, the dimension for mass is m, while volume is L raised to power 3. You can also write it as ml L minus 3. The denominator L is coming up there. So that's that for density. Another quantity, we want to look at speed. Speed. When you open speed, what you say is distance over time. You must be able to know. You can see that I'm only looking the textbook for the quantity. I'm not looking at the formula. So it will be part of you for life. It's not just secondary school level. You are still going to use it in your university. Speed is distance over time. Speed is distance over time. So in terms of the unit, we have distance is meter, time is seconds. So or it can be written as e raised to power 1 can also become mx minus 1, just as we said there, mx minus 1. Then the dimension meter is L, while time is seconds. T, that's L over T, or LT minus 1. So it can be given to you like that in that form. Point over time. The difference between average speed and velocity is average speed is distance over time, while velocity is displacement over time. They both have the same unit and the same dimension. The difference between distance and displacement is this. Distance. Distance is the space between 2 points. For example, here, there's a distance from here to here. So the length from here to here can be 20 meters. That's my distance. But if I ask someone to walk without considering direction, okay, when someone moves from one point to another, and the distance between that space of the person moving from one point to another with no specific direction is what referred to as distance. But when we talk about displacement, we're talking about distance in a specified direction. I can say Olaolu walk due north. That's displacement. Olaolu walk due west. Olaolu walk with a displacement of 30 meters northwest. Or Olaolu walk a distance of 30 meters in 15 degree northwest or 15 degree northeast, or Olaolu walk 50 meters due north, due south, due west, due east. That's a direction. So distance is the space between 2 points with no specific direction. While displacement is the space between 2 points in a specified direction. So please try and take note of that. And every speed is a scalar quantity. Why velocity is a vector quantity. We are still going to discuss that later under scalars and vectors in physics in SS2. I think that's your first topic in SS2 that we'll be addressing. So velocity is displacement over time. So from here, we can now say in our unit is equal to meter per seconds. Meter per seconds. So m over s or ms or meter per second or ms minus 1. Then in terms of the dimension we have L over T or LT minus 1. Both of them are correct. So we are part of our work. So that is done. 6. We move to acceleration. Acceleration has to do with change in velocity. Over change in time. So you can see acceleration is this symbolizes change, something like a delta sign, v over change in t, which means we have final velocity, initial velocity, final time, initial time. So it's denoted with meter per second divided by second. So one thing you should take note of over this acceleration is that we have change in velocity over change in time. The change in velocity, that's an aspect of motion we're still going to do. We have initial velocity. If your vehicle is leaving your house, the initial velocity is 0 meter per second. When you start it using the ignition key and you are moving, you are at a particular velocity. Maybe you now stop at 30 meter per second. That's your final velocity. The time at which you are starting may be 0 seconds. Then when you get to your final destination, it's now maybe like 1 hour. So that would be like 3,600 seconds. The 60 minutes times 60, that's conversion. So that's the illustration there. So we have velocity meter per second over second. So we are still going to divide it. So to be able to get the unit, from the unit we get the dimension. The continuation of our work, if you know that this is meter per second, so it's more or less like meter per second divided by second. That's the interpretation of the unit there. So we now have, when this one turn to multiplication, you interchange this. That's meter per second times 1 over s. So at the end, we now have meter per second square, or ms minus 2. And that's the unit for acceleration. That's the unit for acceleration. Acceleration is the positive change in velocity over time, while retardation is the negative change in velocity over time. We are still going to dwell more on that too. When we start motion, we are going to do motion 1, motion 2. Yeah, doing a lot of calculations around that. I can assure you, just keep following us. You won't regret this. I promise you. You can't follow us and not have this teacher in your physics. We'll be doing it for years. So you can't follow us without not having decision in physics, in maths, in chemistry, in further maths, and in your computer too. So keep following us. We can assure you of that. So the dimension, for the dimension, we know meter is denoted with L, while seconds is denoted with 2. T is denoted with T. That will be T squared. So it will be written like this, or LT minus 2. LT minus 2. So that's that. So we'll look at force. Force is mass times acceleration. That's force. Mass times acceleration. So from force, when we open force, we meet mass and acceleration. Mass is a fundamental quantity. Acceleration is a derived quantity. When we open acceleration to find velocity over time. So that you can see the way it is interconnecting. So there is a strong bond or interconnection between force, mass, and acceleration. So those are the things you need to understand in physics. How one quantity leads to another quantity. So we can say under our unit here, we have mass as kg, the acceleration as meter per second square. So this over 1 kg times m will be kgm. Why? 1 times second square, that will be second square, which can also be written as or kgm s minus 2 kgm s minus 2. That's for the units there. So that's that in its derivation, kgm x minus 2. So that's balance. So then don't forget to, we name force after a man who did a lot of derivation as far as motion is concerned. His name is Sir Isaac Newton. Yeah. Science, in the science world too, they name unit in the name of scientist. For example, Faraday did a lot of work around electricity. So capacitance, the capacitance of a capacitor is named after him using the unit farad. You can see 1 microfarad, 2 microfarad, 3 Faraday, 4 Faraday. You're still going to do much around that in electric field, 1 in SS3. So the same thing applicable to force because of the work and derivation of the discovering and invention of Isaac Newton. As far as force is concerned, we also name the unit of force after him. So you might not see force as 2 kilogram meter per second square. You might also see it as Newton. So though it's a compound name, we can't find the derivation of that Newton. You can only use this one to find the derivation of force. So, but still a unit too. So 2 Newton. You see something like Newton. Newton, yeah, Newton. 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 So you see something like maybe you see something they write something like 2 Newton, 3 Newton. You know that they are referring to force. So those are some of the things you need to take note of there. Thank you. kg m plus minus 2. So we have the dimension. The continuation. So since the unit of force is kilogram meter per second square, so the dimension will be, this is m times l, then times t raised by minus 2. So it will now be mlt minus 2. That's the dimension for force. So work or energy. So work done or energy. So when we look at work done or energy, work done or energy is force times distance. Distance. So in terms of the unit, we have mass. Let's open the quantity of mass times the acceleration. That's for force. Then times the distance. So you can say from here, the unit is kg for mass. Here's meter per second square. Distance is m. So this over 1 over 1. So at the end, the unit is equal to kg m times m, that's m square over s square, the denominator. Kg times m, mass, kilogram, acceleration meter per second square, distance is meter over 1. So kg times m, kg m square, 1 times s square times s square, s square, or, as I've told you, the moment a denominator is, the denominator has a power. For you to become a numerator, the power of that denominator base will be negative. So here can be kg m square s square minus 2. So both of them are correct. The work done can also be illustrated as under force times distance. We can make it without opening the force. You can make it of Newton too. Like, I said force is named after Isaac Newton, then the distance in meter. So it can be Newton meter, that is n dot m as Newton meter. Newton meter or joules. So it could also be named after that. But beyond that, for the dimension, so you can see work done on energy as joules. Even at times, especially for energy, you hear us talking about 2 kilojoules, that's 2 times 1000 joules. 3 kilojoules, that's 3 times 1000 joules. So for the dimension, we will be m square, that's minus 2. So for that, we cannot, because here will now be, the dimension will be ml square t minus 2. The kilogram is m, which is mass. The meter is L. The seconds is t. So that will be the dimension for work done. So let's look at the power. Power. Power is work done over time. Since we've done the calculation for work done on its own, so we can now say for here, you know that here will be, we know that work done is force times distance. So here will be kg m square over s square. That's for work done in terms of the unit. So divided by seconds. So here we want kg m square over s square multiplied by 1 over s. This is equal to kg m square over s raised to power 3. Because this over 1, it will come inverse here. The root that change, then we have kg m square s raised to power 3. The dimension of power, you know, the unit is kg m square over s raised to power 3, or watts. Yeah, that's the compound unit. At times in some of your work on electricity, you see something like watts. It's also a unit, it's a compound name. Just as we have joules for work done, we have Newton meter for work done to energy. But for power, we have make use of watts too. So in terms of the dimension now, so the dimension here, this is the unit. This is the unit. So we want to do the dimension now. So this is for the unit. So we want to use the dimension here, kilogram, that will be m. The meter is L square. This is 2 raised to power 3 seconds. Or, so I have or m L raised to power 2, 2 raised to power minus 3. That will be the dimension for power. That's the dimension for power. So we move to prayer. Number 10. Then prayer. Permit me to pick from the force over area. Prayer is force over area. So which in terms of units can be Newton per meter square or nm minus 2. Force is Newton, area is meter square. So still the same thing. nm minus 2. So likewise, or we also for the unit of prayer, we can also say that since we have force over area, so for do the vibration around, force is mass times acceleration. Acceleration over area. So here can be kg times m over s square divided by m square over 1. So here can also be kg over 1 times m over s square multiplied by 1 over m square. M square means m times m. So this cancel one of this. So then we have kg, this kg over m s square, or kg m is raised by 1, m minus 1, s minus 2. So it's still the unit of prayer. So just as we stated too, because we are going to, from here, we can easily get the dimension for prayer here. From before, we took out Newton per meter square. We can also, or Pascal. This can also, prayer can also be named after, the unit of prayer is also named after Pascal. So we're still going to discuss that when we start discussing prayer on its food. Also, so from here, we can now say that the dimension will now be, if we look at a kilogram, that's m meter, L 1, T raised by 2. So it can be written in a data frame like m L minus 1, T minus 2. Then we say the denominator. The power of that denominator, when it becomes a numerator, become negative. The power of that denominator, when it becomes a numerator, become negative. The mission of prayer is this. Okay? So that's the dimension of prayer. For the young modulus, we have the young modulus is the ratio of the tensile stress over tensile strain. The ratio of the tensile stress over tensile strain. Stress, we have force over area. Force over area. Then we, for the tensile strain, we have extension over length. So the Young modulus is tensile stress over tensile strain. Now, here is F over A divided by E over L. So at the end we have F over A times L over E, which is F L A E. So under the unit, so for the unit, we have this force. So force is mass times acceleration times length over area times extension of the unit. The mass is kilogram, acceleration is meter per second square, length is meter over 1 divided by area is meter square, extension is meter. So meter. So at the end we now have kg m square over s square divided by m raised by 3. That mass kg, acceleration meter per second square, length is meter, the area is meter. So from here we can now say that kg m square over l square multiplied by 1 over m cube. Related kg times m times m over s times x times 1 over m times m times m. Cancel this, cancel this. So then we now have kg over m square. Okay, is it clear? So after that is done, we can now, that's for my young modulus. So the dimension will be, so dimension is equal to m over l t square or ml minus 1 t minus 2. So that's the dimension for young modulus. So thank you. That's all for now as far as dimension part 1 is concerned. When we'll be using dimensional analysis part 2, but before then, every derivation we've done today, try and work it out yourself. Study it. After you're done with the study, close the note, then write 2 or 3 dimension or quantities rather, then derive the unit and derive the dimension. By the time you do that repeatedly, then by the time we start the dimension analysis in form of an expression, you'll be able to be used to us. We'll be doing a lot of comparison of maybe a quantity at the right hand side with another quantity at the left hand side that will be in form of a dimension. And we'll be able to solve as many past questions as possible. I can assure you, both in our indices, in our dimension, we're still going to do a lot of past questions. So henceforth, you've seen index notation 1, 2, 3. We are still going to produce 4, 5, 6 that involve past questions. So please just follow us. You have a lot to learn. Trust you that you've learned a lot since. Thank you. Love you all. We are grateful.